Good day, beautiful people. Swift here. You're watching Swift Tuition, and in this video, I'll be covering solving simple exponential equations. So how to match your bases, use reciprocals, and apply exponent laws. For more free maths help, use the first link below in the group description to join your Grace free WhatsApp group. I'll be sharing selected resources, updates, and occasional free sessions there. If you want weekly tuition, full worked out solutions, recordings, and the premium group, launch prices are going to be $350 to $450 until the 31st of August, depending on your grade. Prices are going to be doubling on the 1st of September. You'll find both links below. In this problem, we're asked to solve for x, and we're given 3 to the power of x plus 1 is equal to 81. Okay, so 3 to the power of x plus 1 is equal to 81. At first sight, does not look like something that's easily solvable, right? Because you haven't dealt with it as of yet. Okay, but something to bear in mind, this is my golden rule for always working with exponents, is to write everything as a product of its prime factors. Because once you do that, a lot more is going to become available or visible, noticeable to you. That's the important thing to bear in mind. Okay, so what does that mean for me then? This is 3 to the power of x plus 1. I'm going to press 81, click equals on my calculator, press shift, and then press the button that has like weird symbols like this, essentially, right? Like a bunch of comments or whatever. You'll see something like facts in yellow if you have the later Casio calculators. Once you do that, this will take this 81 and write it as a product of its prime factors. So look at this. This is 3 to the power of x plus 1, and you'll realize that 81 is 3 to the power of 4. Now, if these two things are equal, right, you know that 3 to the power of 1 is not equal to 3 to the power of 2, right? 3 to the power of 3 cannot be equal to 3 to the power of 5. Those are completely different numbers. So if you have some particular power, the powers have to be the same, right? In other words, like 3 to the power of 3 is equal to 3 to the power of 3, right? 3 to the power of 5 is equal to 3 to the power of 5. In other words, 5 is equal to 5. That's the understanding I want us to establish over here. What does that mean for us? This means that I can rewrite this problem as such. This is 3 to, I've already written it, right? 3 to the power of x plus 1 is equal to 3 to the power of 4. That must mean that the exponents must have been equal for these two to be equal. Therefore, I can say that x plus 1 has got to be equal to 4. Therefore, x has got to be equal to 3. And that's the answer for that. And you can verify that, right? What if x is equal to 3? Well, that'll be 3 to the power of 3 plus 1, which is equal to 3 to the power of 4. And that makes sense because 3 to the power of 4 is equal to 3 to the power of 4. Next problem. Now, this is 2 to the power of 2x minus 1 is equal to 128. Again, same procedure, right? This is 2 to the power of 2x minus 1. And we know that 128 is the same as 2 to the power of 5 is 32, 6 is 64, 7 is 128. So taking this into consideration, therefore, that must mean that 2x minus 1 has got to be equal to 7. I take the 1 to the other side and I've got 2x is equal to 8. And then I divide both sides obviously by 2 to get the x by itself, and I get the fact that x is equal to 4. X is equal to 4. Okay, and we can verify this again by checking. This is 2 to the power of 2 times 4 minus 1. And I said 128 is obviously the same as 2 to the power of 7. And this is 2 to the power of 8 minus 1, 2 to the power of 7. And that is correct. 2 to the power of 7 is indeed equal to 2 to the power of 7. All right, now, Swift writes two different looking powers on the board, but both sides can use base 2. And we're asked to solve for x. Again, we want to be able to use the same base, right? Because again, something to the power of b is equal to something to the power of b, right? Whatever that thing is in the base, if they have the same base, then we can perfectly line them up and equate the exponents to each other. Okay, so now this is where we have to be a bit more careful when we're rewriting problems such as this. And remember, 8 itself is 2 to the power of 3. So you want to put that all in its own set of brackets. That is 2 to the power of 3. That is 8. Start with that. And that 8 is raised to the power of x minus 2. And then this is 4, right? But 4 itself is the same as 2 squared, and that 2 squared is raised to the power of x plus 1. This means for me that I will basically be distributing the 3 with this guy and this guy, which would make this 2 to the power of 3x minus 6, and then obviously 2 to the power of 2x plus 2. Where is that coming from, Swift? Think about the fact that we need to multiply, obviously, right? When we have anything to power of b raised to a further power c, right? This is the same as having a to power of b times c. Now, if b is 3 and c is x minus 2, I'm doing 3 multiplied by x minus 2, which means I must distribute the 3 for both of these terms, giving me 3x minus 6. Same thing can be done to this guy to arrive at 2x plus 2. Now their exponents must be equal to each other, therefore, so that'll basically mean that therefore 3x minus 6 has got to be equal to 2x plus 2, and then we'll bring this guy to this side, that's x, bring the guy to the other side, that'll be 8, and that'll be our solution for that. And then again, you can check the answers yourself. I'll leave that as an exercise to you, where you take the 8 and you plug it in over here, and you plug it in over here, and see if you get the same answers for the left hand side and for the right hand side. And you should have a calculator to just verify that, to make sure that everything does indeed line up. Okay, now this is where it gets a little bit trickier, but again, same procedure, write everything as a product of its prime factors. So this is 5 to the power of x, which is being equated to 1 over 125. Now you should know that 125, or you use the shift button on your calculator, 125 is the same as 5 to the power of 3. Now this is not quite where I want to be, but we're close. Okay, please bear in mind that when you have 1 over anything, you can bring that thing to the top, and that becomes thing to the power of -1, right? Or in other words, you can think about the fact that the 1 is still technically there, it's just obviously invisible. So that's what happens in that case over there, right? When I bring it towards the top. So when you bring something towards the top, you can make the exponent negative. So that means that therefore 5x is equal to 5 to the power of -3. And then that means, okay, and then therefore x must be equal to -3. And yet again, you can verify this by plugging it into your calculator and seeing that you get the same solution. Okay, that's that. Then the next portion is going to be question 5, and in this case over here, we have 4 to the power of x is equal to 1 over 32. Right, 4 is not a prime factor, so I'll write as a product of its prime factors. That's 2 squared, right? And then obviously raised to a further power of x. And this is 1 over the 32 itself is the same as 2 to the power of 5, right? But I want to bring it to the top so I can line them up nice and neatly. Obviously, that's 2 times x, so that'll just be 2x is equal to, and bring this guy to the top, that'll be 2 to the power of -5. I can equate the exponents, giving me 2x is equal to -5, and therefore x must be equal to -5 divided by 2. And that would be how you'd approach a problem such as that. Now, Swift's answer card shows a reciprocal power. We want to solve for x. Okay, again, same procedure. We want to say that this is obviously 9, which is the same as 3 squared. That whole thing is 9, and you raise it to the power of x minus 1. Please do not neglect your brackets, because the whole 9 is 3 squared, right? You want to show that that is whole, that's the complete 9, right? Lots of people make the mistake of saying 3 squared, and then they will say x minus 1 or something. That is not the same thing, okay? So please don't make that mistake. It is going to cost you dearly. All right, and that's going to be equal to 1 over 3 to the power of 3. I want to bring this guy to the top, of course, and multiply this guy out. That'll be 3 to the power of 2x minus 2. Again, I'm doing 2 multiplied by x minus 1 and distributing throughout. And that is going to be equal to, I bring the 3 to the top, and that makes it 3 to the power of -3. I equate the exponents. That makes it 2x minus 2 is equal to -3. I bring people around. That's 2x is equal to -1, and I divide by 2, and that gives me x is equal to -1/2, and that is not the right answer. Is the right answer 3, 9? Yeah, it should be the right answer. Yes, it is. Okay, sorry, had a bit of a brain fart there. Okay, next question. We're asked to solve for x. Now this one's a little bit tricky. No, it's not. I thought it was a different type of problem. Okay, solve for x, and we've got what you can see over there, right? So my advice to you is you want to have the terms with the x's by itself, or the term with the, or the part of the expression with the x by itself, and then everything else towards the right. It is not a golden rule, because in this case it'll work either way, but it is my advice to you. So I'll first of all show you my advice to you. This is 2 to the power of x multiplied by 2 to the power of 3 divided by 64. So my advice to you is to make this 2 to the power of x and then 64 divided by 2 to the power of 3. So in other words, I'm bringing the 64, I'm bringing the 2 to the power of 3 to the other side, right? That's 2 to the power of x is equal to, well, 64. Instead of 64, I can say, I think about every time, 2 to the power of 6. 2 to the power of 6 divided by 2 to the power of 3. And then obviously I'm dividing, so I'm going to subtract the exponents. That'll be 2 to the power of 3. And therefore, x is equal to 3. All right. In this case, though, you wouldn't go wrong if you first of all apply the fact that if you're multiplying, you can add the exponents. So that's 2 to the power of x plus 3 is equal to 2 to the power of 6. And then obviously, therefore, x plus 3 is equal to 6. And again, same procedure, x must be equal to 3. So you arrive at the same answer, but it's just a matter of methods that we need to be careful about. Okay, so again, we're going to look at this one over here. Now we'll use my preferred method. In this case, we have 5 to the power of x plus 2 divided by 5 to the power of 3 is equal to 125. I'm not saying that it's the most effective method, by the way, every single time. I just want to use that as a pattern that you can basically apply to multiple larger scale scenarios, right? So in this case over here, that's 5 to the power of x plus 2, right? When I'm adding the exponents, that means that the original things must have been multiplied, right? It must have come from this problem. So I'll write it first of all like this. I'm going to take that and divide it by 5 to the power of 3, and that's going to be equal to 125 is 5 to the power of 3. Okay, so now I want to bring this 5 to the power of 3 to the other side, right? In other words, multiply both sides by 5 to the power of 3, which means that now on the left-hand side, I've got 5 to the power of x times 5 squared is equal to 5 to the power of 3 multiplied by 5 to the power of 3, because I multiplied both sides by 5 to the power of 3, all right? And then now I've got 5x times 5 to the power of x times 5 squared is equal to 5 to the power of 3 times 5 to the power of 3, all right? And remember, I like to keep the x itself by its own, so I'll just say 5 to the power of x, and then that'll be equal to, and that'll be obviously 3 times 3 makes it 5 to the power of 6, but I need to I divided both sides by 5 squared to get the 5 squared out of the left hand side, so I'll do that on this side as well, all right? Which means therefore that 5 to the power of x must be equal to 5 to the power of 6 minus 2, right? Because I'm dividing, I must subtract the exponents. That's 5 to the power of 6 subtracted by 2, and therefore 5 to the power of x is equal to 5 to the power of 4. And therefore, x is equal to 4. And that's how I'll derive the solution for x in this problem, right? So cool. Then we'll look at the next problem. A power lock opens when the left-hand side equals 64, and we're asked to find the value of x. Okay, so now this one's a bit more tricky, but again, nothing that we can't handle, okay? Again, always write things as a product of its prime factors. This is 4, but I know it as well as 2 squared, which I can raise to the power of x plus 1, and then obviously divide all of that by 2 to the power of x minus 1, and then that'll be equal to 64, which is just 2 to the power of 6. Okay, and then I'll distribute the 2 out, and that becomes 2 to the power of 2x plus 2 divided by 2 to the power of x minus 1, right, is equal to 2 to the power of 6. Okay, and then obviously because of the fact that I am dividing, I can subtract the exponents. That's 2 to the power of 2x plus 2, right? Put in brackets minus, and because I'm minusing the entire exponent, right? So please do not forget the brackets here. That's x minus 1. Some people just go say minus x minus 1. That will not give you the right answer. Remember, you subtract the entire denominator, the entire exponent in the denominator, and that'll be 2 to the power of 6. And then from here, I've got 2 to the power of, that's 2x plus 2. The minus with this positive x becomes minus x, and the minus with this negative 1 becomes positive 1, and that'll be 2 to the power of 6. And from there, I can say that therefore 2 to the power of 2x minus x, I'm just grouping the x's with the x's, and I'll say plus 2 plus 1 is equal to 6, and then simplify, I get 2 to the power of x plus 3 is equal to, it's not 6, it's equal to 2 to the power of 6, 2 to the power of 6, and therefore x plus 3 is equal to 6, and therefore x must simply be equal to 3. And that would be how I'll derive the solution for that. Okay. That is about that. Obviously, please do join the free group chat for more extra practice questions and to download this PDF and such.